What is going on, everybody, and welcome to a tutorial slash showcasing of the Keras-Tuner package. So one of the most common questions I get on deep learning tutorials and content in general is people asking, how did you know to do n number of layers, or why n neurons, or why did you do dropout? Why did that degree? Why batch norm? All these things, like why did you do that? And the answer to that question has always been trial and error. And anybody who tries to tell you that they knew what model neural network was going to work is a dirty liar. It's trial and error. Now, of course, there's some tasks like MNIST, for example. A paper bag could solve MNIST to 90% accuracy or more. So obviously there's some problems that are just so simple any network will do. And then there's some neural networks that will solve most problems, like especially like image problems, stuff like that. But for real world problems that aren't solved yet, the solution is trial and error. And this has historically involved me writing for loops to solve it. And then in that for loop, I just tweak things. And then I run that overnight, and then I save like validation accuracy or loss or both. And then in the morning, I just see, okay, these are the attributes, like 3 layers at 64 nodes per layer. It seems to be the thing. And then, you know, now I'll test with batch norm, because every time you change one little thing, like dropout or not, 50%, 20%, 10%, batch norm or not, and all those things, you got to keep testing. So anyway, it's historically just been ugly for loops, to be honest with you. But recently I came across the Keras-Tuner package, which does everything I was doing, but better. And it does a few other things that I wasn't even doing, which is pretty cool. So I thought I would share it with you guys. Basically, the crux of it is you've got a model, and then you can define little hyperparameter objects inside that model, and then you create this tuner object, and then it changes those hyperparameters. And the hyperparameters you can specify, you don't have to, not everything has to be a tunable parameter, but the ones that you do are, you can do anything like an int, float, you can do a choice, a boolean, and the ints and floats are like a range with a step size. So anyways, that's pretty cool. To get it, you just pip install keras-tuner. Also, I'm using Keras-Tuner 1.0.0 now as a tutorial person. This throws up tons of red flags for me, but I'm still going to do it anyways. But 1.0.0 means one of two things. It either will never get updated again, which would be sad, or two, it is going to be updated a ton in the next year, and this tutorial could be rendered out of date very quickly. If you're hitting errors, check the comment section, Google the errors, or you can pip install Keras-Tuner, the exact version that I'm using. So once you have that, you're ready to get started. But first, a quick shout out to the sponsor and supporter of this video, Kite, which is an ML and AI based autocomplete engine for Python, and it works in like all the major editors: Sublime Text, VS Code, PyCharm, Atom, Spider, Vim, but why? Anyway, all the major editors, and it's actually a good autocomplete. Honestly, I hate autocomplete. So when they reached out and were like interested in becoming a partner, I was like, we'll see. But it's actually pretty good. It took me a little bit to realize how good it was. And in fact, I've used it for about 100 hours now. And the real test was when I removed it, like I just disabled it, and just to see what the difference was. And I was like, oh, wow, there's so many big differences. The biggest thing is like the autocomplete, it's not just variables, it's like methods and even like snippets of code, and like the imports are so much nicer. Huge differences. I'll show some of them here, but I highly encourage you guys. I'll put a link in the description for you guys to check it out. It's super cool. And it comes with Kite Copilot as well, which is kind of like a standalone app, if you want it anyways. And basically it's like live updating documentation for whatever you're working on, which again is super useful. So yeah, it's a really exciting sponsorship. I don't take like any sponsorships, if you haven't noticed. Like I don't do VPNs, mobile games, all that stuff, because it just doesn't really make any sense. But this is actually a really cool product. So I'm excited for them to be supporting the free education, and I definitely suggest you check them out. It's the autocomplete is the best. Okay, cool. So let's go ahead and get started. So first we need a data set and we need a model. There's like so many things that we need just to even get started with Keras-Tuner. So I'm going to try to like truncate this as much as possible. But first we need a data set. The data set that we're going to use is Fashion MNIST. So it's like MNIST, only like I said, MNIST is like too easy. So it's kind of no good for showing this. So we're going to use fashion MNIST. So I'm going to say from tensorflow.keras.datasets, we're going to import, and again, just as a quick example, here are all the datasets, fashion MNIST. So then fashion MNIST dot load data is what we need to load the data. And then, just to shill out completely, kite copilot, come down here. It returns this right here. So I'm actually just going to copy and pasta this. Since most people probably aren't running Kite Copilot right now, you can go to the text-based version of this tutorial or download Kite real quick. Anyway, so here's all your data. And I think I'm just going to show like a quick visual example of the data, and then we'll probably just copy and paste a model, honestly. I don't want to waste too much time. So first, let's just quickly display one of the data. So we're going to say import matplotlib.pyplot as PLT. Lovely autocomplete. Thank you very much. plt.imshow. Oh, no. It tried to help me. Imshow, and then we'll do xtrain. We'll go with the 0th, and then plt.show, and then I'm also going to do a cmap equals gray here, only because it's going to be all colorful if I don't, and people are going to be wow, that's loud. Mute that. People are going to be kind of confused. So I'm going to say Python 3.7 Keras-Tuner tutorial. So this is kind of the data. So again, it's a 28 by 28 like MNIST. It's black and white. It's got 10 classifications. It's articles of clothing rather than handwritten digits. So in this case, it's like a boot or a shoe of some kind. I don't really know what that is, but okay. So let's do a different one. Let's see. Hopefully we can get something a little more recognizable. Possibly. Okay, so it's some sort of shirt, sweater thing. Okay. So that's what we're dealing with. So it's just a little more challenging to get like 98% accuracy as compared to like MNIST. So this is a thing that we can practice tuning on. MNIST just doesn't work. So once we have this, we actually need a model. Now again, I don't really see any benefit in this tutorial for me to like write out this entire model for you guys. It would just be a waste of time. So I'm actually just going to copy and paste. I'll either copy and paste this into the description, or I'll put a gist, or you can just go to the text-based version of the tutorial. But this should all be, except for this HP here, this should all be totally understandable by you guys. There should be nothing here that is like, whoa, what's that? So, and then, so hyperparameter, or this HP stands for hyperparameters, which is what we're going to use to go through. This is a comment that I made for the actual tutorial. So this just creates our model object, returns the model. Pretty simple. So from here, you could define the model and do a .fit, for example. So the other thing that we need to do is import. So let's go ahead and from TensorFlow, from TensorFlow, we're going to import Keras. Then we need to import all that layer information. So from tensorflow.keras.layers, import all of these basically. We're going to need every single one. So dense, actually we're not using dropout, but conv2d, yes. What else we got? We got activation, we've got a flatten, and we've got some max pooling. Cool, done. Ran over my face a little bit. Again, there is the text-based version of the tutorial. And again, I'm really just trying to run through this. There shouldn't really be anything confusing to anybody here. So once we have this, real simply, we can test this. I just want to make sure it works. So I'm going to say model equals, what do we call that? Build model, yeah. So then from here, we should be able to say like model.fit. Yet again, cool thing from Kite is like this entire snippet, boom, done for you. And then you can kind of tab through it. So for example, batch size, let's go with 64. Epochs, so then again, I'm just tabbing through that, which is pretty cool. Validation data is going to be a tuple of information. In this case, what were we going to do? We're going to say xtrain, ytrain. So xtrain, or xtest rather. Oh, it tabbed me over. X test, Y test. And then actually in this case, I don't care about verbose. I had it there because I was building this tutorial in a notebook first. So, okay, so then we can do that. Oh, we need to have our X data. So X train, and then this will be our Y train. And we need to reshape the data before it complains to us. X train equals X train dot reshape, and it's -1, 28, 28, 1. Again, if this is confusing to you, I strongly encourage you to go back to one of the deep learning playlists. Okay, so that should all work. I do want to test it real quick to make sure it works before we get into the actual tuning aspect of things. So I'm going to save, run that again. Please work. Oh, it's because we have that HP there. Let me just move it real quick. Put this back. Please work. Whoa. Okay, so it's training. We can actually see it's already working. We could just go to one epoch. So for example, after one epoch, it's actually not that accurate, like 77%, not much. But whatever you got, I can just tell you it's not above 90%, okay? So the question would be, okay, what do we do from here? Like, can we actually do better than this model? So the fashion MNIST dataset is still easily learnable. What's not easy is being 99% accurate as opposed to like MNIST. So what you would do from this point, like if you're me and you're trying to compete in a Kaggle competition, is now you're just going to start changing stuff. But what we can do with the Keras-Tuner package is we can like automate that entire process. So what I'd like to do now is I'm going to move that over and we're going to import a couple of things. Again, I'm going to try to keep this super short, so I'm going to, as short as possible anyway, I'm going to just copy and paste that in. So from Keras-Tuner.tuners, I'm going to import random search, and then from Keras-Tuner.engine.hyperparameters, we're just importing hyperparameters. And again, these are the things that allow us to do like the int, the float in ranges, choice, boolean, and I want to say there's another one, but I forget it. But anyway, again, text-based version has links to like all the docs. I'm just trying to show you a general idea of how all this works. The next thing I want to do is I'm going to import time, and then we're going to specify logdir equals, and for now, yeah, eventually, this is kind of a silly one, but anyway, this is a stupid F string to use, but whatever. Time. For now, the logdir will just be a timestamp, but you could add other things to this if you wanted. But again, trying to keep it short and simple. So, okay, so build model, now we will pass the hyperparameters, and so far, nothing is actually unique here. So the next thing that we're going to do is I'm going to come down to the very bottom here, and I'm going to comment out these two things, because this no longer will even work. And in fact, I'm just going to get rid of them because that build model is no longer functional in the way that we have, as long as we're going to pass hyperparameter there. So, we're going to first, you're going to specify the actual tuner that we intend to use, and that's going to be a random search. And here, we're going to pass a bunch of things. First is the actual function that we intend to use, build model. No parms there. The random search object here will automatically do the hyperparameter stuff for us. So you just pass the function name here for your model. Then we've got objective. This is the thing that we're interested in tracking. So in our case, val accuracy. That's what I'm interested in. Then we're going to say max trials. I'm going to set this to, for now, I don't know. For now, 1. We have no dynamism here, so it doesn't matter. So I'm going to set that to 1. I'll explain that in a moment. And then we're going to say executions underscore per trial equals 1. And then we just give it the directory. So directory equals logdir. Cool. So so max trials and execution per trial. So trials is how, so like options can explode very quickly when we're allowing ourselves to have a dynamic number of layers, a dynamic number of nodes per layer or features per layer. And then a bunch of Boolean operations like, do we want dropout? And then if we do, what range of dropout, right? This can explode to like thousands or even millions of combinations pretty quick. Like with a 2-layer confident, pretty hard to get to millions, but it can get to a huge number. Like 1,000 different combinations of models is not going to be very hard. So here, when we say max trials, this is just how many random pickings do we want to have. And then executions per trial, this is what you would, like if you're just trying to search for a model that learns at all, then I would keep this to 1. If you're trying to eke out the best performance, I would set this to like 3 or 5 or maybe even more. As long as you're like shooting in the dark, just trying to find something that works or just a general idea of what seems to work, I would keep this low. But the point of this is each dynamic version, you're going to train it this many times. So if you've got some sort of, when it randomly says, hey, let's do 4 layers at 64 nodes per layer, it will train that 1 time. But you might want to say 2 or 3 times, because if you're trying to eke out like 1% accuracy, given 2 different runs from the exact same model, you might find that you get more than a difference that's higher than 1%. So if you're really trying to eke out performance, 1, you might be seeking a model that has a smaller standard deviation of validation accuracy, but also you might want to run it a few times to figure out what the true average is, because you might have just gotten lucky, or maybe you got unlucky or whatever. So hopefully that makes sense. If that doesn't make sense, feel free to ask in a comment below. So that's our tuner object. And then now what we're going to do is actually do a tuner search. So tuner.search. And in this case, we're going to specify our X data, which will be X train, and then our Y data will be Y train. And I think I'll go ahead and tab that over. Actually, I suppose if we want to be all, I think it's correct, Pep8 to remove those. X, Y, and then we need epochs. So how many epochs do we want to train every single time? Again, this really depends on your needs. I'm going to set it to 1 just because to iterate over this stuff, it still is going to take a while. And in fact, we're probably not even going to do it. But locally, I'm just suggesting maybe start with 1. Batch size, again, this is going to vary by, what you're running this on. I'm going to say 64. And then validation data, I did. Dang it. I got to type it. Validation data equals, I've been so spoiled. I haven't really had to type too much. X test and then Y test. Okay. So now what this will do is search given these parameters, right? And then what kind of stuff is it going to search? It's going to be based on this information here. We're only going to run 1 trial. Again, I'm going to just quickly run this to do a bug check, and then we'll actually start making the model truly dynamic. So, cool, runs, good. So now what we're going to do is come to our actual model and start adding things that make it dynamic. So first of all, so for our input layer, let's say we take 32. And we want 32 to, yeah, sure, maybe be 32, but maybe we want it to be anything from 32 to 256. But we don't want to say like 32, 33, 34, right? We want to have a step size there. So the way that we do that is hp.I int, and then we're going to give it a name. And so I'm going to say input, input units, not shape. And then it's the starting value, max value, so 32 to 256, and then the step size. I'm going to say 32. So, and in fact, I'll just add the actual names to this one. I'm not going to do it every time, but just to make it super clear, min value, max value, and then this is our step. So I'm just making sure it's on screen. I'm not covering it. So now the input units is a dynamic value that will be randomly chosen, but somewhere in that range. Okay, so yeah, it looked good. So again, I'm going to save that really quickly and just make sure we run no bugs. Cool. So in theory, that is with a different, who knows what, I don't know which one it was in that case. The tuner does save all that information. I'm just, again, bug checking at this stage. So random search. And so okay, we've got a unique or a dynamic number of for the input to this convnet. And then we can come down here, and then so the input layer is a little unique because it has an input shape that we need to make sure we retain. But then the subsequent model or the subsequent layers can are all basically the same. And in fact, I'm going to remove max pooling because that's going to cause trouble for us. We're going to run out of things to pool if we, in some cases. So I'm going to remove that. And now we're going to say is we're going to for I in range. And again, we're going to pick HP int. And then the name in this case will be n underscore layers. And we will go from 1 to 4. And since we want the step size to be 1, we don't need to input anything more. So from here, we'll do that. So now, model add conv 2D. And then again, what if we want this 32 again to be unique? So I'm going to take HP int here, copy that, paste that over that 32. Rather than input units, I'm actually going to say underscore I. We'll make this an F string. And I'm going to say conv I units. And again, 32, 256. Cool. So, looks good to me. Model add relu. Okay, I think that's good. We can go ahead and save that. Let's come down to here. Go ahead and run that. Make sure it runs. It does. Okay, so I could continue to let that run, and in fact, it might, let's see, I think we said 1 epoch, so hopefully at the end of at least 1 epoch, it should give us a brief summary, I would hope. Oh, that's right, we said only... So at the end of it, okay, so we can see, fine. In this case, we had a neural network, so that input convnet was, so the input units was 32. Then we had 2 conv layers, so it's a little bit out of order actually, but the input unit was here, right? So we actually had a 32, so it was 32 by 96 by 32. Not by, but each layer. So the input layer is 32, like the convnet has 32 features, and then it feeds into a 96 features, then a 32 features. So it says n layers is 2, but it's actually 3. It's plus 1 more. It's just n layers is the answer to this for loop here, right? So the actual number of layers is n layers plus 1. I hope that makes sense. Coming back down here. So then this tells us what the score is. It also tells us what the best step for that score was, which is useful, but we only did 1 epoch anyways. Okay, so we get the information, but of course this was relatively meaningless because we only tested one thing. So the next thing to do would be to make this a much bigger test. But each test takes, this says 19 seconds. So, and it's going to vary depending on how many layers you do and all that. So it's just going to vary. What I've done is I went ahead and created, I just went ahead and saved it as a pickle object. So I took tuner at the end. You get this tuner object. So at this stage, all I did was imported pickle. I saved the tuner object to a pickle. Thought I had saved it, but I made a mistake, so I ended up just retraining everything. So here I am, like an hour later. I've got my pickle, I've got my directory, and just to really quickly show you, inside this directory and then inside of Untitled Project, we have all of the trials that ran, and then for each of the trials, we have a checkpoint, which obviously is the model, and then the trial.json file contains obviously your ID, but then the hyperparameters, more importantly, and the score that model got. So even if you didn't have the pickle, you could still go back in time and get this stuff. But anyways, it would be kind of challenging and tedious and annoying, especially if you've got many iterations per trial. You'd have to pair up, I guess, by exact hyperparameters. I don't really know. Anyway, it would be annoying. So it's nice to have the pickles saved instead, just to come back later. So, so yeah, so cool. And so you have that. And then also I want to say here you've got, is it the Oracle? I think it's inside the Oracle that has the best information. It's definitely not tuner 0. But you can also interact with the tuner object, which is why I saved it as a pickle. So first of all, we can get the best hyperparameters right out of the gate just by running that. And in fact, before I do that, let me comment out this, and then we don't want to do the search again. So I'm going to comment that out. Cool. Okay, so let's just run that real quick. And we get here like the best hyperparameters. Now, I don't really find that very easy to read, but then the next thing that is a little more useful to me is the results summary. So this should give us the top, I think by default, top 10 models. So here they are. And as we can see here, the top 10 got, basically the best was 87, but it's anything from 86 to 87. It's, you know, within, what, 5% accuracy, it looks like, or 6. So pretty close there, and also 87 is the very best. Interestingly enough, in the other one that I trained that I lost, the best was 89.6. So I do think we could for sure find something more than 90, and if you run this, it's totally possible that you'll find some that are better than 90. And the reason for this difference is, even though it seems like we made very minimal things to make dynamic, we actually did a lot. And so to actually run through all of those, I don't actually totally even know. So you could have up to 4, and then 4 layers of each unique convolutional layers, and then of all of those combinations times all the possible combinations here. I mean, it would just be a huge number. It's got to be hundreds or even in the thousands. I don't know. Someone go ahead and do the math if you want. Anyways, it's a lot. So there's a lot of combinations, but that just goes to show that I already know that somehow with this exact code, you can get actually 89%. It's just a function of running through all the combinations. So again, it's very nice if something can do it just automatically for you. So finally, the last thing I will show is that you can actually, from here, get the actual model. So a TensorFlow model. So print tuner.get best models, and then I'm doing a dot summary here, but this is an actual model. So you could actually do a dot predict as well. I'm just going to do a dot summary just so you can see it. I think this is the easiest way. Like the hyperparameters is still kind of hard to be like, okay, but how would I build this model again? Whereas a dot summary really just makes a lot of sense to me. So anyway, we'll just do that really quick. But mostly it's just to show you it's an actual TensorFlow model. So as we can see, you got the input layer, activation, pooling, right? So you just build this model exactly to this to these specs. So, okay, I think that's enough information. Hopefully you guys have enjoyed. Like I said, this is like one of the most common questions I get. The answer is probably not as intriguing as you maybe would have hoped, but hopefully Keras-Tuner can actually make your lives easier. If you have questions, comments, concerns, whatever, feel free to leave them below. And again, shout out to Kite. If you want to try them out, it's a totally free plugin. And like I said, it's pretty awesome. Like I've been really enjoying it. So hopefully you guys will enjoy it as well. And thanks to them for supporting the video. That's it. I will see you guys in another video.